Okay. Auzu billahi minash shaitanir rajim. Auzu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Today your science teacher is here with a new chapter, Sound and Hearing. And today, inshallah, we will have an introduction of this chapter. So let's see that what is our today's objective. Our today's objectives are that how sound is produced. Okay. When describe how sound needs a medium to travel through, means when sound is produced, first we will learn that how sound is produced, and when sound is produced, how and why it needs a medium to travel through. What are the different types of mediums? We will learn about it. And then it travels at different speeds through different media. Okay, that will be a very interesting objective today, inshallah. So let's move ahead. This is the introduction. First, we need to know, students, that what is sound. So the vibrations that travel through the air or other medium and can be heard when they reach a person's or animal's ear are called sound. Okay. So vibrations are basically the true and fro motion of anything. Means when we speak out, it makes certain vibrations, certain disturbances in the air. Definitely our medium is air, but it can be any other. We will talk about it later. So these disturbances start traveling in the air, and by traveling through the air, it can be heard and it reach to our ear or any animal ear, then it is termed as sound. Okay, so how is sound produced, as it was our first objective? Number one, sounds are caused by vibrations. Take this key point into your consideration, students, that sound will always be produced when there is some vibration. I already told you what is vibration. It is to and fro motion. What is a to and fro motion, students? When something vibrate on its fixed position backward and forward. Okay, it remains fixed to its position, but it moves backward and forward. That is called to and fro motion. So sounds are, that is the key point, that sounds are caused by vibrations. Vibrations are considered as a disturbance that travels through a medium. Okay, I already told you air is a medium, and for other mediums we will talk about later. So this vibratory motion, means this motion which has been caused, which has been generated, it produces an energy. Okay, it causes this energy of sound to transfer to our ears and is interpreted by our brain. Okay, these vibrations travel through air, comes to our and reach to our ears. When it is reached to our ear send this vibration then to our brain. Our brain interpret these vibrations, and then we are actually able to hear a sound. Okay, students. So next to it is that sound is a form of energy. Okay, it's a form of energy. It means that the necessary condition to produce a sound is vibration of a particle. Okay, now see what I mean by vibration. You can see over here, this is called a tuning fork. It is a very important apparatus and instrument in um, the study of sound. So this is called its prongs. Okay, these are called its prongs. You can see that it is its original position, but when we hit this prong or tuning fork with a rubber pad, it starts vibrating in this way. A little bit it moves here, a little bit it moves here, but actually it remains fixed to its original position. That type of sound is called as to and fro motion. What it is called? To and fro motion of a particle about its mean position, means about its fixed position, is called as vibration. Okay, students, so I hope that till now you have understand that sound is a form of energy. Like there are many other types of energy, so sound is also a form of energy, and it is always carried in the form of waves. You can see these waves over here now. Okay, you can see these type of waves over here, and the necessary condition to produce a sound, as I told you earlier, that it must have the vibration of a particle. Okay, so let's have some examples over here. You can see a drum over here in this picture, that when we hit the drum, the membrane of the drum vibrates, producing sound. Okay, when we hit it, it produces vibrations, and this membrane starts vibrating. When it vibrates, it starts generating waves, and these waves travel through air and reach to our ear. Our ear detect that vibration, send it to the brain. The brain interpret the sound, and then we are able to hear the sound. When we play a guitar, if we talk about this guitar, the string on it, you can I hope every one of you know that always there are some strings. Okay, strings are there on a guitar, makes to and fro motion, means it again moves about its mean position and produces sound. Okay, and sound produced by a vibrating prong of a tuning fork also is a good example of sound. Okay, now you can look into these musical instruments right now. Okay, you can see this guitar, you can see this clarinet, and even you can have a choir over here. So even the sound produced by different musical instruments, they also need a certain medium to travel through. Okay, in guitar, it is the strings that vibrates. When they vibrate, sound is produced. Okay, in a clarinet, the air column inside it vibrates. This is a full column being made. A full column is there, and air travels into it, and when the air is there, it helps to um, produce the sound by vibration. Okay, and even when the singers, they sing in a choir, even their vocal cords, I hope we have learned about it, about the vocal cords. They are present on our neck, and when we speak, if we hold our thumb or finger on our vocal cords, when we speak, it vibrates, it shows the sensation of vibration, and then we, even humans, are able to produce the sound. Okay, so this is the way that we can see that musical instruments, even they produce the sound. Okay, is that clear, students? Okay, coming next to that, that how sound travel. How sound travel. Sounds, if we are listening to a drummer, this is one of the example, of traveling of sound. So it says that if we are listening to a drummer in a band, we do not have to put our ear on the drum. Why? Because the sound travel when the drum skin is struck. When the drum skin is struck means when it is being hit, or when it is being beaten, the drum skin vibrates. As I already told you, this drum skin, it starts vibrating. When it vibrates, the vibrating skin makes the air molecules vibrate backwards and forward. I already told you that it starts moving backward and forward, and which these molecules affect the molecules next to them, and the sound start spreading. Okay, it start spreading. Within a split of second, all the air molecules will be vibrating. We hear the sound when the air inside our ear starts to vibrate our eardrums. Okay, so when the drum skin is struck, it creates or it generates the uh, vibrations. These vibrations causes the air beside the drum to vibrate. Okay, the compression and stretching. What is this compression and stretching? This is basically that, again I will tell you that the forward and the backward movement of the waves, these compressions and stretching of air again creates vibrations or the waves, and after that creating a sound wave which is carried through the air to your ear. When it reaches our ear, it hits our eardrum, and that eardrum sends the vibration sensation to our uh, brain. The brain interprets it, and this is how, students, we are able to hear our sound. Okay, I hope every one of you have well understand till now that what is sound, how sound is produced, how the musical instruments impart in sound producing. They even need certain vibrations, or they even have some special parts in their musical instruments for vibrations. Like in guitar, it is the string; in clarinet, it is the air column; in choir, it is the um, you can say that it is the vocal cords which vibrates and produce the sound. Okay, and then I have demonstrated and given you this example of drum, that how the drum produces the sound, uh, and it reaches to our ear, and after reaching to our ear, how we are able to interpret the sound. Okay, I hope every one of you are very clear till now. Okay, now I'm moving to the next. Yes, this is a very interesting experiment I'm going to explain with you all. Okay, sound waves need a material to travel through. Remember it, students. This is a very important point. Okay, it says that sounds can only move when there is a material to move through, and this material is called a medium. Remember, okay, the material which sound waves need to travel through is called a medium. Without it, there is nothing to pass on any oscillations. Oscillation is another term used for vibrations. It is another term can be used for compressions and rarefactions, as I already told. It is another term you can use for the backward and the forward movement of sound. Okay. And before going next, I want to add up that sounds can travel through all substances, whether they are solids, liquids, or gases. Yes, students, it is not necessary that sound only travels through air. Even sound can travel through liquids. In your higher classes, inshallah, you will learn about it. And even sounds can pass through solids. Okay. And in fact, sounds can pass anywhere there are particles, and more tightly packed the particles, the further the sound travels. It shows and it tells us that sound travels fastest in solids. Yes. Why? Because in solids, the particles are always tightly packed together. Okay, so I hope you have understand that sound waves need a material to travel through. This material is called a medium. Okay, whatever it needs is called its medium. Without this medium, there is nothing to pass on any oscillations, any type of movement of or vibrations, whatever you say. Okay, but now we need to know that what is a single medium or only medium where the sound cannot pass or cannot travel. Okay, students, so sound cannot travel through a vacuum. Vacuum means when it is completely empty space. Okay, when it is a completely empty space, that is called a vacuum. So the experiment below is to prove that sound waves need a medium to travel through. Okay, so students, this is the apparatus for checking this question, that why sound cannot travel through a vacuum, and the name of this apparatus and experiment is bell jar experiment. You can see an inverted glass made jar, and it is shaped like a bell. That's why it is called as a bell jar. Okay, so this bell jar, it is having an apparatus, and you can also see into your books that it is having an electric bell. It is attached with some wires, definitely, because you can set any loudspeaker into it, and this must have a connection with a battery. Okay, and you must have some vacuum pump over here, because this vacuum pump will help you to pass this or remove or add the air into it. Okay, so put the electric bell into a jar. You can put any loudspeaker into it, you can put any electric bell into it, and remove all the air inside the jar with the help of a vacuum pump. So this um, outlet for vacuum pump will help to take out the air anytime, and even to let the air inside the bell jar also. Okay, so this, when we connect this bell into the battery and switch it on, definitely the bell ring, but no sound hear the outside of the jar. Why? Because we have taken out all the air out of it. Now there is only a vacuum around it. That's why you cannot hear any sound. This means that sound required a medium to travel through. Okay, it always needs a medium to travel through. So now, actually, I want to demonstrate this experiment in front of you to check that how sounds travel through a medium, and how the sound cannot travel through a vacuum. For this, I would like to demonstrate a video in front of you for the working of this bell jar experiment. Let's have a look. So for demonstration students, I'm going to show you a video. Let's watch this video for the functioning of this bell jar experiment.
Sound needs a medium to travel. So let us perform first experiment, which will show that sound travels through air. Take an electric bell and an airtight glass bell jar. The electric bell is suspended inside the airtight bell jar. The bell jar is connected to a vacuum pump as shown in figure. If you press the switch, you will be able to hear the bell. Now start the vacuum pump. When the air in the jar is pumped out gradually, the sound becomes fainter, although the same current is passing through the bell. After some time, when less air is left inside the bell jar, you will hear a very feeble sound. When air is removed completely, a vacuum is created and we won't be able to hear the sound at all. Now allow the air to enter the bell jar slowly. You will find that the sound of the bell goes on increasing as the amount of air in the bell jar increases. So students, it is clear that sound needs material medium to travel.
So that is the end of our today's topic. Stay home, stay safe, and God bless you all.